Hello there, hope you're all doing fine despite the crisis, and thank you for taking the time to watch our video. As a fast forward, this presentation is about an unconventional setup. We created a special mirror that allows you to watch others play in virtual reality. So how does game spectating usually work? Well, in most cases, we just see what the player sees, which is sufficient for most non-VR games. However, virtual reality is different. VR is all about immersion. So for us as spectators, it is also important to see the full body interactions of the player in the respective gaming context. So what solutions do we have? The most prominent one is the green screen. In this case, we have to film the player and then merge this video on top of the game canvas. Now, we went for a different approach. You probably know smart mirrors. These are one-way mirrors with a display on the backside, so you can display some additional information on top of your reflection. We wanted to utilize this technology and to take the player's reflection and merge this reflection with the game world. So instead of filming the player like in a green screen, we just want to utilize the reflection of the player directly to see the player in the virtual environment. Unfortunately, reflections are position dependent. So we always need to know where the spectator actually is and to adapt the view frustum based on the spectator's position. Surprisingly, this is also the biggest selling point of our idea. This dynamic view frustum allows you to explore the game world on your own by just repositioning. So by simply walking in the room, you obtain a novel perspective and you can notice some game events that you would have missed with a green screen. So let's explore this idea step by step. So first of all, we need to track the spectator in order to generate this dynamic view frustum. Then all we have to do is to utilize our favorite algorithm for a mirror implementation from computer graphics, and we are done. Next is the player's reflection, and this is where the one-way mirror comes into play. So in our case, we just build the mirror on our own, but of course you can just buy a commercial solution. One thing to know about one-way mirrors is that they only reflect areas that have a dark background. So unfortunately, we cannot see the player right out of the box. What we have to do instead is to render a dark silhouette at the position where the player's reflection should be. For simplicity, we can just assume that the player's contours are a dark blob. So the last challenge we have to solve is to determine where this blob should actually be. The whole computation is grounded in the law of reflection. As we know the viewers and the player's positions, we just insert P and V into the equation, and after a while we obtain a closed form expression for one dimension. Then we have to repeat it for the remaining two dimensions, and we are done. So what we have in sum is a combination of a dynamic view frustum and the player's reflection at the correct position. So as a spectator, I can just now walk in the room and I will always see the player's reflection at the correct position. So here's a short outtake rendered from the viewer's perspective. As you can see, by slight repositioning or just moving your head, you can adjust the view frustum so that you don't miss any important events, and you always see the player's full body actions in the respective gaming context. We also conducted an exploratory study just to see how people actually perceive such a setup. So the 9 participants first watched a gameplay session of the examiner and then had to fill in some questionnaires like the IPQ. Now at the end we also displayed a number of possible silhouettes to the participants just to determine whether there is a perfect solution. It turned out that actually the simple blobs perform best because they are least distracting. As for other results, we gathered a lot of interesting ideas and requests. So for instance, most participants asked for games where they could actually interact with the player, which means that our setup tends to lower the barrier induced by such virtual reality setups. Another appreciated feature was this dynamic view frustum. So the first few minutes, the participants usually just walked in the room and explored the virtual environment, which is a novel level of autonomy. On the downside, nearly all participants complained about the mirror size. So the mirror was just way too small, which forced the viewers to stand really close to it in order to obtain a sufficient field of view. Furthermore, the current setup works for one viewer only, which limits its applicability to public spaces. And we need an access to the game engine in order to create this dynamic view frustum. So now, in sum, what do we have? Clearly, it is not an ultimate and everyday solution. But it is a novel and surprising experience that is fun. And we still believe that it has some undiscovered potential that can further emphasize and empower the spectators. Thank you very much for watching. I'm looking forward to your questions.